that's the benefit of flexible PCBs, I think, that you are basically exposed to new ideas when it comes to flexible. There is nothing you cannot do. So basically, it's like adding an extra dimension to PCBs.
Hello everyone, and welcome to the Altium On Track podcast. I am your host, Zach Peterson, and I'm sitting down today with Carl Bugeja, a well-known YouTuber and electronics engineer. He always does some interesting stuff with projects, and so we definitely want to talk to him today about some of his favorite stuff, some of his background, and how he got started doing what he's doing. So let's go ahead and get into it. Carl, thank you so much for sitting down with me this morning. Actually, it's morning for me. I'm sure it's afternoon for you because you're across the pond in Europe.
Yeah.
So my timing is a little off because I just got done doing Altium Live and it was 3 a.m. But I'm still happy to be here talking to you because you're a pretty well-known face on YouTube and in the engineering community. And I also saw that you spoke a few times with the guys at Hackersmith about some of your projects. So that was pretty cool.
So for anyone who don't know who I am, maybe I basically do electronics. That's what I studied, and then I currently post YouTube videos about the projects that I'm making.
Yeah, I thought some of them were pretty interesting and certainly some stuff that I would not have thought of. But maybe just for the audience, you can kind of tell us your background a little deeper, and then how you got into PCB design and electronics design.
So basically, I studied electronics engineering at University of Malta. I graduated in 2016, and that's when I started designing PCBs. And then after graduation, I first started a startup with my friend. After a bit, we stopped working on that startup and we're working on some cool project ideas like drones and Bluetooth alarm tags and stuff like that. And then after 9 months, we ran into some financial problems. And right after that, I basically started working, but in my free time, I was still very into the robotic stuff. So I decided to start documenting everything and putting it on YouTube.
How did you get started using Altium? Was Altium one of the first tools you used? Did you maybe start learning with something like KiCad or a different program?
So back in my first year of engineering, they actually taught us a software that I don't think it exists today. It was called Proteus. Then in the third year, I got introduced to Altium Designer. I had a couple of lectures about it as well. And I also designed some interesting stuff during my university days with Altium. And that's how I basically got started. Then I also used it in my automotive job for around 3 years, and that's basically how it got started. Yeah,
that's interesting. I think a lot of people get started on a free program or something like maybe like Proteus or something like that, and then they kind of move up to a more advanced program like Altium.
Yeah.
How do you like approach a new project, and what were some of your first projects that you created when you started doing YouTube videos?
So my project usually starts like me thinking about an idea for like a couple of months, and that's basically how every project got started. Me getting curious about something weird or something that doesn't exist. I think that's the main the main the way I approach a project. So basically, it's stuck in my mind for around a month, and then when I like figure out every little detail, I basically open Altium Designer and start designing. I usually start with the layout and then schematics. Sorry, I usually start with the outline, then schematics, and then go through the layout. My first project that I posted on YouTube was the PCB Motor. So basically it was based on the idea of having PCB coils printed on the PCB itself, which are used to actually rotate a rotor.
Yeah, I saw in quite a few of your videos you were basically putting the coils for like a motor onto a PCB, and that's something I certainly never thought of. And you know, you had I think you were talking to someone from Hackersmith, or not Hackersmith, Hackaday, I should say. It was one of the Hackaday, yeah, one of the websites, and yeah, you had mentioned you know, putting this onto a board, and then I didn't even think about it, but then like stacking multiple layers to increase the turns density, and I thought that was really interesting. I mean, do you try and get really innovative like that with everything? Because I thought that was a really interesting way to actually do something that was essentially to create motion, and essentially just, you know, powering it up with magnetic field, putting it near another magnet.
Yeah.
Yeah.
So basically, how that project got started, like I said, I liked the idea of simplifying a drone. So a PCB motor was actually my first idea on how a drone could be simplified, because you would obviously have everything integrated on one PCB. The idea didn't quite work out because the motors didn't generate enough thrust for it to be feasible. And for it to be implemented on a drone. But as I've showed on my channel, it can be used for other things, like maybe a wheeled PCB robot. So I think to think about having a robot that from a manufacturing point of view, it's simplified and having the less amount of components possible, I find that very interesting.
So with one of your projects, and I noticed that you do quite a bit with robots, and you know, they'll be soft robots, and that's really interesting because like soft robotics, I think, is one of these things that's been talked about sometimes in like the research literature, or maybe you read about it in IEEE. I've never actually seen anything with soft robotics, but you're actually doing it with like flex, you know, flex elements in some of the stuff that you've built. And then I thought that was pretty interesting. Yeah,
I don't think it's technically soft. It's considered as 100% soft robotics because you obviously need to have some rigid parts, and you obviously need to have the magnets and stuff like that. But I think it's an interesting concept that, I think there's few people researching right now.
Yeah, and then especially with like making it foldable or making elements of it foldable, it's like which elements are best to make it to become, you know, the soft portion of the system. And one other thing that I thought was interesting was like there was one I was scanning through your YouTube channel, and there was one little robot that looked like you were building that basically like unfolds and then opens up, and you know, all of the circuitry is like crammed inside of there. And it seems like if you go with the soft route, put everything on flex, you can really pack a lot more features and a lot more components into this, you know, really tiny package.
Yeah, sure.
And then the thing pops open and just, you know, opens up and can start moving.
Yeah, sure. That's the benefit of flexible PCBs. I think that you you are basically exposed to new ideas when it comes to flexible. There is nothing you cannot do. So basically, it's like adding an extra dimension to PCBs. So I basically have some projects coming up that, for example, I have one that is about making a ball made out of LEDs. So that is something that is very hard to do with FR4 PCBs. So flexible PCBs gives you a new way of playing more around and creating a concept that maybe was difficult to do with previous FR4 PCBs.
Sure. I wonder, if you're doing, if you're someone who is, maybe a hobbyist and, or maybe you don't need to do flex professionally, how does someone get started learning flex? Like, what were some of the resources that you had available, or did you actually just learn at university?
No, at university, we never learned about flexible PCBs. The way I learned on flexible PCBs, I obviously made some research on the internet and YouTube and stuff like that, but there's not a ton of information available. So it was basically trial and error. So I learned from my mistakes mainly.
And then I ask because I run my own firm doing design, but I've never done flex that's been like produced and manufactured for somebody. And so I think for someone who has never actually had to do it production grade and go take it in to get manufactured, it's you still have to rely on somebody else to do the majority of the work, or you have to try and figure out some resources to learn. So but that's interesting that you're able to get in and figure it out, and then use some of those flex elements as actually as the mechanical element. And one thing I noticed in one of your one of your projects that you had going on, it looked like you were actually using the flex ribbon with a nearby magnet, and like I believe the electromagnet was built into the flex ribbon. So you essentially just power it up, it moves back and forth between two magnets.
Yeah, so using...
So that's interesting. Basically, go ahead.
I was using the flex Taylor ribbon as an arm, sort of, as a way, as a return mechanism, sort of.
Yeah. So, what are some of your most challenging, types of projects? Is it the flex stuff? Is it the really compact foldable stuff? What are some of the most challenging things that you've had to build?
I think one of the most challenging aspects that I face is making a design feasible, sort of. You can make, for example, one of my projects is about one of my popular videos on YouTube is about a jumping PCB. So basically version 1 was just an H bridge with a PCB coil and a magnet that actuates itself and jump. So that sounds a very cool idea, but when you look at the feasibility aspects, it doesn't have a battery on board, it doesn't have a microcontroller on board, and when I did put those things onto the PCB, obviously there's quite a bit of difference. So perhaps I think the most challenging aspects are the line between making a prototype or a concept and making something that can be actually manufacturable and feasible from a real life application point of view. For example, one of the challenges I face is the Lipo batteries. my robots are usually very small, and it's very hard to find batteries that have that are small and also have a large current capacity.
Yeah, and then I'm sure that they have to, discharge fast enough in order to actually deliver the power needed to give you enough, thrust essentially to lift the board up, as well as all the components.
Yeah.
Yeah. And so it sounds like the challenge there is, not just the engineering of, how do I deliver power to an electromagnetic element, but then also how do I minimize the weight here on the PCB and of all the other components?
Yeah, I mean, with flexible PCBs, it tends to be quite light, because I mean, I usually some of my PCBs are usually less than 1 gram, which flexible PCBs, I mean, will allow you to achieve that quite easily, since they are less than 0.1 millimeter thick.
Sure. And then, I mean, if you're taking a board, you're essentially, forcing it to jump on its own, just by, giving it some power. What's the control to make it land the way you want it to?
That's the challenging part.
I mean, if it's just a flex ribbon, it's attached to something, right? So the flex ribbon is just going to recoil and come back down. But, what if you just had like an isolated board and you try to make it jump,
Yeah, I mean, that's the challenging part. Obviously, you would need to add some sensors there, and try and control the way the feet land of the robot, of the PCB.
Yeah. So that would have to be controlled, like with a microcontroller or something.
Obviously.
So for anyone who is interested, maybe, what are some resources that you use to learn how to program to do embedded?
So basically, when I graduated, I wasn't very good at writing firmware for microcontrollers, but I mean, the best way I think I learned from writing firmware is by doing a ton of projects. In fact, I mean, I started as an electronics design engineer when I used to work full time, and then after a few months, I needed to switch to writing firmware. So basically, what I used to do before YouTube was writing firmware for some automotive switches and stuff like that. So I have some background on the firmware side of things as well.
Yeah, I will admit I'm not the best coder either. I mean, I can do some things in Python, but okay. I have to rely on other people when it comes to writing firmware. So that's interesting. It sounds like you got some, on-the-job experience, and then maybe, apply that over to some interesting stuff with projects.
Yeah, I mean, I have some experience. I am not an expert, but I mean, with time, it comes naturally. Writing software. I mean, you obviously bugs are always necessary, but I mean, it's part of the job.
So what have you been working on lately? What are some of your most recent things that maybe haven't gone up on the YouTube channel?
Yeah, okay. So I'm currently working on a couple of things, mainly for projects. One of them, like I said, is the RGB ball. So I'm making, hopefully it will work, a ping pong size RGB ball that has 242 LEDs. It's going to be all made on one flexible PCB. So the flexible PCB itself will fold into a ball, hopefully. Another project that I'm working on is flexible PCB heaters. I'm also doing some interesting stuff with that, hopefully in the coming months. I will also investigate some wearable applications when it comes to flexible PCB heaters. And I'm also working on a new PCB robot that has 4 wheels and will be made just from one flexible PCB.
So from a single flexible PCB for a robot with wheels. That's interesting because, you know, with the wheels, it sounds like you're going to have to take advantage of some kind of enclosure to mount all of that, and then you have to essentially put the flex PCB inside of that. Is that kind of the approach?
Yeah.
Because, I mean, you need to keep those wheels essentially rigid somewhere.
Yeah, so basically what I'm using is using stiffeners as the outer shell of the robot.
I see. So you're doing a rigid flex type of approach.
Yeah, sort of. It's still a flexible PCB, but it has different type of stiffeners. I mean, it has some FR4 stiffeners and some metal stiffeners at the bottom, which will hopefully keep everything rigid. And then where needed, there will be the flexible areas as well.
So, you know, when you're starting with like a flex PCB and you have stiffeners, you said both FR4 and metal. That is this the kind of thing where you generally take the design to like a preferred fabricator, and are you actually doing the assembly yourself, or are you also doing assembly through somewhere external, like through doing it overseas or something?
Yeah, the assembly I usually do it myself. I enjoy doing it, and I think it makes the videos more interesting. Obviously for the PCB, the manufacturer just review the design files and perhaps even give some feedback, but that's it.
Yeah, so you're actually taking the manufacturer's feedback, even on a hobby project. That's something what we stress around here at Altium is design with manufacturing. So take their feedback because they definitely want to help you be successful. And I know that I have to rely on manufacturers as well, even for simpler questions. And, you know, it's definitely an area of the industry that I have tried to learn quite a bit more about over the last year or so, just because having to put more things into manufacturing, it's really important to know how to deal with them, know how to talk to them, know what kind of resource they can be.
I think it's very important.
So it sounds like you do have to lean on your manufacturer. Yeah,
I think it's very important to build a good relationship with your manufacturer.
Yeah, definitely. And do you have like one or two preferred ones that you use? Do you just shop around by price? Because I mean, I know with hobby projects you probably don't have, you know, infinite budget, and I mean it's understandable, right? If I, you know, for some of the hobby stuff that I've done, I'm not, you know, allocating huge sums of money to it.
For me, obviously, all of my PCBs are usually sponsored by a specific manufacturer. So over the years, I built quite a good relationship with them, and I mean, I highly recommend them. So,
well, that's cool. Yeah, you get to form a relationship, and then I'm sure they get some exposure on the channel.
Yeah, sure.
Yeah. Well, that's very cool. Well, what we're going to do is in the show notes, we're actually going to link to your channel. Maybe I can follow up with you before this goes out, and maybe you can, you know, give me a few links to some of your videos for some projects you think are that you personally find most interesting or most challenging.
Okay.
I think the audience would enjoy that. What do you think?
Yeah, sure.
Okay, great. Well, Carl, it's been really great to talk to you, and you know, I hope the audience goes and checks out your channel and gets inspired by some of the really interesting designs that you've done. Because you know, when I first reviewed your channel, I was looking around and I thought, wow, I had never thought to build a board like that, or I'd never thought to build a little robot like that. But you know, it seems like your mind is just in a different spot in terms of some of the designs that you've done. So that's really cool.
Thank you very much.
Okay, so I think we're going to wrap it up there. Everybody please go look in the show notes and go to Carl Bugeja's channel and check out some of his great videos and learn all you can. And maybe I hope someone will get some interesting design ideas from watching your watching your videos, because I do think they're
Yeah.
very interesting.
I mean, my projects are all open source, so if somebody would like to,
Oh, that's
yeah,
true. Yeah, they
So-
are all open source.
if they would like to continue experiment perhaps on some project or they have some other ideas they would like to try, they can also visit the open source files.
Yeah, that's a great idea. Yeah, I'll admit, sometimes I'm not a fan of open source, just because having to do commercial stuff, everyone wants their own IP and they want it to be private. But for what you're doing, that's awesome that they're open source and people can get in and participate.
Yeah, the open source community is always growing, so I truly believe in it, and I think it's the future. So,
Do you ever start a new design starting with open source? Are you also someone that'll take a design, clone it,
I don't usually
totally change it,
No.
put it out there as something new?
I don't usually do that, mainly because I like when I start a new project, I like to start from like step one. So I usually, even from code, for example, it's hard for me, for example, to use somebody else's code, because you're missing, you will sort of miss some features. But I mean, just for trying out something, it's magic.
So, well, what we'll do is in the show notes, we'll actually link to your GitHub page.
Yeah, sure.
So hopefully people can go there and access some of your projects. I actually have your GitHub page open on another tab, so we'll definitely link there, and people can check out some of the work you've done. So, Carl, thank you again so much for taking some time to talk to us. Everybody in the audience, make sure to check out the show notes. Go check out Carl's channel. Make sure to go visit his GitHub page if you're looking for some interesting resources. And we hope to see you again next time for the next episode of the podcast. Don't stop learning, and of course, stay on track. Thanks, everybody.